Now these are some of the radicals. So these are radicals. We treat them like one atom. When you're trying to form a compound in an equation, we treat these radicals to be a single atom, like they are inseparable. But we're going to look at the definition when we come to topic of radicals. But what I want to show you is this. Now, I'm going to start with an atom, a simple atom. An atom is made up of uh, four major components. The major, then we have some minor. Let's assume this is a what? A nucleus. This is a nucleus. The middle, you know, I think you've looked at our solar system where we have the sun and orbits with planets. That's how even an atom resembles it. So, assuming this is like our sun, then these are the orbits where the planets. So, this is our nucleus, the sun in the solar system. Then we have this called the shells. They go by many names. Most common is they are just rings. Now, what do these rings do? On them, just like our solar system, we have different electrons. Moving on this, these shells hold these electrons. In a nucleus, so this E is going to be representing our. In the nucleus, we have particles known as protons and neutrons. Now here's the catch. These are how many? 5. Let's say these are the 5 major components of an atom. Protons are known to be positively charged. These ones have a positive charge. Electrons have a negative. Protons have a positive, electrons have a negative charge. Neutrons, of course, I think the word was derived from the word neutral. They do not have any charge. The what? A single charge. The what? Yes, something like that. They have 0. I had like that saying, right? Now, we're saying protons are positive, electrons are negative. Now, there's another catch. When it comes to mass, protons have mass. That means they have weight. Neutrons have weight, but electrons, their weight is negligible. It's too small that we take it to be 0, like they have no weight. Negligible comes from the word neglect. You can neglect it because it's too small. Now, these ones have charge, neutron doesn't. But when it comes to weight, the ones in a nucleus have weight, the rest we take them to be weightless. So that means most of the weight of an atom comes from this nucleus. But then the charge is much determined by these electrons and protons. Now, to make a table will look like this. neutrons also, for electrons, we're going to take near because negative. Take them out. Let's go in the basis. Don't move this. They have a mass, but they're saying it's very small. Like even light also has a mass. Light. But the mass of photons is too small to the extent we don't have a scale that we can do. So we take it to be too small. We don't have a scale in the lab that can measure anything. But with different scales, they made the ones for electrons make it. We make it and just say we take it to be 0. Instead of putting 0, we just put 0. But it's so small, it's in a 0.0000000. I think up to the other side of the block. So this one is too small. So now how does this help us? Knowing the number of protons and electrons helps you to determine the charge. Then the mass also helps you. Knowing the number of protons and electrons also helps you to weigh the atom. No. Like I said, knowing the number of protons and neutrons help you to determine the mass of the atom, which in this case we are calling the atomic mass. Atomic mass of an atom. Now when you look at the definition, it says the atomic mass, the number of protons and why? Because they are the ones that actually have mass, which is significant. So we take protons and neutrons to be our atomic mass, and they are found in the nucleus. So to get the mass number, just get the number of protons plus you just add them. Now each element here has different number of protons. We find some different number of neutrons. What? You what? This is like a trailer. Like, Mr. Can you allow me download the movie trailer?
Yes.
You people download movie trailers?
Yes. What you consider the movie? Yes.
Sorry, you can. Huh? Elements in No. This is just standing for one atom of that element. Standing here, one atom. That means every one of these has protons, neutrons, and electrons. Zina byonna, full package. All these are just representing one atom, single. It can't be an electron on its own, but an atom can have a charge of negative, single electrons zisuka protons, but it can't be an electron. Now what's buzzing in my head is, what are these people writing? It's like you're in a Chinese lesson and you write down every single thing you first see the teacher writing, but you actually don't have much of an idea.
The next time they're talking about this, my head connects very fast. What is going on?
Okay, that makes sense. So you show me that you revised. Oyinza ogenda n'olekerawo okozesa wired. Notandika owuliza nga ffe abaaki. Yes. Ng'obuuka kireza bonna mulina sipiidi yammwe. Batwala mpola tukumemu. Yalaba trailer. We are going to look at atomic number. Number this in a. You mean atomic mass or atomic number? We are going to look at atomic numbers of each one of them after you master the elements. Some at least. Naye abiri mu mutwe ng'entandikwa. Allow me to continue. Now is the catch. We said the number of protons and neutrons make what we call the atomic mass, the mass of an element. So if we have let's say an element A. Let's say we have an element A. That element A, we are going to indicate a figure somewhere here, like maybe X, then Y down here now. The element A, okay, let's use an element we know. We use which one? Carbon. They will indicate carbon, and then you put a figure somewhere up, a figure down here. The figure up here represents the atomic mass. That means the mass of this, the mass of the whole atom. But down here indicates the number of protons alone. the number of protons alone. Why would they go for protons alone? It's here. That number is called the atomic. They're saying the atomic number is the total number of protons in the nucleus. Now what confuses people is atomic mass and atomic number. Now the catch is, when they want the mass of an atom, they always put the word mass. While they say mass number or atomic mass, as long as you see the word mass, just know they want the mass of the atom. For atomic number, there won't be a word mass. No. The number of protons is known as the atomic number. Atomic number. Now why would they want to know, why would they consider protons alone? And they even have their own space just to show them. Because they help us determine a lot. Charges, majorly for level charges. The catch is the number of protons in a stable atom. If an atom is supposed to be stable, the number of protons is equal to the number of electrons. The number of protons is supposed to be equal to the number of electrons for the atom to be stable. Why? These are 4 electrons in this atom I've just demonstrated. We have 4 electrons. Yeah? Electrons are 4. That means the protons are also. Why? Because electrons are negative, protons are positive, isn't it? We have to have an equal balance of positives and negatives. If we have 4 protons which are 4 positives, they will be equal to 4 negatives. And then our atom will be stable. If it there loses an electron, this atom is now going to turn to be unstable. Then it will start, it will start in ebyabawulu ebabukira buli ayitawo. An example. There's an example. So we are supposed to have a balance in positives and negatives, and the atom will become neutral and stable. Electrons move, but we won't have protons moving. Electrons do what? Move. Electrons can move from one atom to another. Protons do not. Protons are thermal. For them, they are always locked in the what? The nucleus. So this atom can gain electrons. It can get electrons from other atoms, or it can release electrons to other atoms. Both of these will be changing the charge accordingly. For example, here we have 4 electrons. What if we have an atom donating an electron? Then they become that means, remember, the protons don't change. We are going to remain with 4 positives, then you have 5 negative charges, isn't it? Now, since the negative is now more, the whole atom is going to be negatively. Once again, it's going to, we even start calling it an ion. Okay? It's going to start being negatively charged. How about if, back to original, 4 positives and 4 negatives. This atom then donates instead. Nekolachi? Negaba kemo. We are going to have 4 number of protons does not change. If you change the number of protons, that means the protons moved. We are going to have 4 protons and 3 electrons which are negatives. They are now filled because one was donated. Now in this case, the protons, the positive charges will be, there will be more. Thus, this will be a positively charged an atom that loses or gains.
What are you talking about as an atom?
The whole thing is an atom. Like I draw a human body here, then you ask me, which organ are you calling the body? This is like the whole body. This is the whole atom. If it's a human, in biology it would be a whole human being. Then these ones would be different systems. Electron wevavo kweno atom number efuuka positive. Lwaki? Because they were originally 4 kati zikendeddemu. Now the positives are what? Are more. Wezikola ki? Anti it shares with another atom. Temuntwala speed. This is what they call chemical reactions. You remember how compounds form? These are chemical reactions. We have electrons moving from one atom to another. We see how they try to balance. So this works.
They just don't take their result. So that I don't go off what you're saying. Like over rings, they will meet the atom is the same thing. And the Ugam atom we're talking about that. As I say, when the electrons move from one atom to another. Like in normal one example process, you know what exactly does that mean right here. So Singapore ring when you're going to ring it. Yes, like
okay, wevuga kuva ku ring emu mpaka ku ring endala.
yes.
Your atom number eba ekyuse cyane. Mwagala nnyo practice. Waliwo atom endala si kyekyo? Now first, if this atom is stable, kuliko electron meka kiba kitegeeza even the protons are what? 4 protons. That means 4 negatives here, 4 charges are balanced. But if it decides to donate, nezigenda ku atom endala, ona losing. You mean my explanation was changed by another diagram? Kale ekirungi tuli kitegeera. So singa eva ku atom emu nedda ku atom ki, awo charges zikyuka. Here wanaaba akoze eki najja eno si kyekyo. That means to this person, to this atom, we are going to remain with the 3 negatives, but the positives are going to remain because protons don't move. Now here the positives are more than the what? This atom officially will be positively. Atom originally yabadde with 1 electron, also 1 negative 1, but they've added this atom another electron. That means now there are 2